Assalamu alaikum. Today we will start from Gauss Lemma. So uh, we are interested in the statement of Gauss Lemma. So the statement of Gauss Lemma is let P be an odd prime. Let P be an odd prime and A an integer such that P does not divide A. Let nu denote the number of least positive residue of the integers a, 2a, 3a till p minus 1 by 2 times a that exceeds p by 2, then Legendre symbol of a over p is minus 1 to the power nu. So that's the procedure, or that's a very easy way to find the Legendre symbol through Gauss lemma. Okay, so because the other procedure that we discussed in the last class or in the previous classes, uh, in those procedures we can only simplify Legendre symbol, or we can simplify integers for the Legendre symbol, but through Gauss lemma we can find uh, Legendre symbol for any integer a. Okay, we just need to find the value of nu, and nu is the least positive residue of the integers that exceeds p by 2. Okay, we are not interested in the proof. Okay, and we are interested in the application of the Gauss lemma. Okay, uh, let me give an example. For example, how to compute Legendre symbol of 5 over 23. Okay, so what is the Legendre symbol of 5 over the prime 23? So A is 5 here, P is 23, So we can find 5 because a is 5. So 1 times 5, 2 times 5, 3 times 5 till p minus 1 by 2 times 5. So p is 11. Sorry, p is 23. 23 minus 1, 22. 22 by 2 is 11. So we have to find integers till 11 times 5. So 4 times 5, 5 times 5, 6 times 5, 7 times 5, 8 times 5, 9 times 5, and 10 times 5, 11 times 5. Okay. Now we have to find the product, and we will consider the products which exceed p by 2. So 1 times 5 is 5. Okay. 2 times 5 is 10. 3 times 5 is 15. 4 times 5 is 20. 5 times 5 is 25, but 25 in modulo 23 is 2. 6 times 5 is 30, which is 7. 7 times 5 is 35, and 35 is 12. 8 times 5 is 40, and 40 is 17. 9 times 5. 9 times 5 is 45, and 45 is 22. 10 times 5 is 50, and 50 is 4. 11 times 5 is 55, and 55 is 9 modulo 23. So now we have computed all 11 values. So we will pick those number which exceed p by 2. So we cannot pick 5 from here. We can't pick 10. We will consider 15. We will consider 20. We can't consider 2. We can't consider 7. 12 can be considered. 17, 22. Then, so nu is the number of integers that are that exceeds p by 2. So that exceed 11. So p by 2 is 23 by 2 means 11.5. So that exceeds 11.5. So 1, 2, 3, 4, 5. So nu is 5 here. Okay. So by Gauss Lemma, Legendre symbol of 5 over 23 is minus 1 to the power 5, and this is equal to minus 1. So 5 is not a quadratic residue of 23. So there are some problems in the computations of the least positive integers which exceed p by 2, because sometimes all of the integer are less than p by 2. Let me give an example. So in that case, we find Legendre symbol in a different way. Okay. So for that case, let me give an example. For example, Legendre symbol of 2 by 3, 2 by 13. So A is 2 here, P is 13, P minus 1 by 2 is 6, and P by 2 is 6.5. So we have to compute 1 times 2, 2 times 2, 3 times 2, 4 times 2, 5 times 2, and 6 times 2. Okay. So 1 times 2 is 2, 2 times 2 is 4, this is 6. Okay. And 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6, and 4 times 2 is 8, and 5 times 2 is 10, okay. So 10, and 6 times 2 is 12. So there are some numbers which are which are exceeding. So nu is 3 here. So 2 by, so Legendre symbol of 2 over 13 is minus 1 to the power 3, so which is minus 1. So it means there will be some integers which are greater than p by 2. So we will have some integers. Okay. So let me uh, introduce another result. Theorem 6. Let P be an odd prime, then Legendre symbol of 2 over P is 1 if P is congruent to plus minus 1 modulo 8 and minus 1 if P is congruent to plus minus 3 modulo 8. Okay. For example, Legendre symbol of, let me give an example, let me write here. Legendre symbol of 8 over 19. Okay. So this can be written as 2 cube 19. Okay. And this can be written as 2 square for 19 times 2 19. We know that 2 square, Legendre symbol of 2 square over a prime is 1. So this is 1 times 19. And what about 19? 19, when we divide 19 by 8, so 16. So we will have 3 modulus 8. So this will be minus 1. Okay, or let me write minus 1, since 19 is congruent to 3 modulo 8. Okay, so now we are able to find the Legendre symbol of 8. So Legendre symbol of 8 over 19 is minus 1. Okay, for example, we have 13. Okay, so we know that 13 is, oh sorry, 13 by 31. Legendre symbol of 13 over 31. So 13 can be written as minus 22 sorry, 13 plus 18 is 31. Okay, so this will be minus 18 by 31. Okay, so minus 18 can be written as 3 square times 2 square, sorry, 3 square times 2 times minus 1 by 31. Okay, so now we can write 3 square 31, Legendre symbol of 2 31, Legendre symbol of minus 1 31. Okay, so Legendre symbol of 3 square is always 1, because Legendre symbol of a square is 1. Then Legendre symbol of 2 by 31. So we know that 31 is, so when we divide 31 by 8, so this is minus 1, because 8 times 4 is 32. So this is minus 1. So whenever we have minus 1, so this is 1. So Legendre symbol of 2 over 31 is 1, and then we have minus 1 by 31. So this is minus 1, Legendre symbol of minus 1. Okay, and we have already discussed in a previous theorem, in the theorem that we discussed in the last class, that Legendre symbol of minus 1 is minus 1 here. It depends on P as well. So Legendre symbol of 13 over 31 is minus 1. So by using this result or this theorem, we can also find the Legendre symbols. Okay. Because and why my Legendre symbol of minus 1 is 31? Because we we have already discussed that Legendre symbol of -1 is -1 to the power p minus 1 by 2. Okay, so p is 31, 31 minus 1 is 30, 30 by 2 is 15, so -1 to the power 15 is -1, so -1 is here. Or you can write formula as well, -1 to the power 31 minus 1 over 2, and this is equal to -1. Okay, then let me give another example. Okay, 9973. Okay, so what is the remainder when we divide 9 when we divide 2 4 2 to the power 4 9 8 6 plus 1 by 9973. Okay, we divide this number by 9973, where where 9973 is a prime. Okay, so 9973 is a prime. So we divide 9973, okay, because it's a prime number. So we divide this 9973 by 8. Okay, then we will have modulo 5. Modulo 5 means this is -3 modulo 8. Okay, so it means the Legendre symbol of 2 over 2 over 9973 is -1 by using the result we discussed here. Okay, so the Legendre symbol of 2 for the prime number 9973 is -1. Okay, then by Euler's criterion, Legendre symbol of 29973 congruent to 2 to the power 9973 minus 1 by 2. Okay, because the Legendre symbol is -1, so we will have same result whether we use Euler criterion or a different result. So this is -1 modulo 9973. Okay, so 9973 minus 1 is 9972, and 9972 divided by 2 is 4986. So it means means 2 to the power 4986 is congruent to -1 modulo 9973 and 2 to the power 4986 plus 1 if we add 1 both sides of the congruence. So we will get 0 modulo 9973. So it means 9973 divides 2 to the power 4986 plus 1. Okay. Okay, let's move to the different result. Next result. It's a corollary of the previous result. For corollary 6. Let P be an odd prime, then Legendre symbol of 2 is -1 to the power p square minus 1 by 8. Okay. Okay, so either we use this result, theorem 6, okay, or the alternate of theorem 6 is corollary 6. So Legendre symbol of 2 over p is -1 to the power p square minus 1 over 8. Okay. Okay, look at the proof of this result. So if P is congruent to 1 modulo 8. So if P is 1 modulo 8, then P square minus 1 by 8 is equal to P minus 1 by 8 times P plus 1. Okay. So it's simple that we just make factorization of P square minus 1. So this is P minus 1 P plus 1. We can write P minus 1 by 8 times P plus 1. Okay. But the thing is that because P is an odd prime, okay, and whenever we divide P by 8 and the remainder is 1, so it means P minus 1 congruent to 0 modulo 8. Okay. So it means P minus 1 is divisible by 8. Okay. And if P minus 1 is divisible by 8, then this number is an even integer. Okay. And if P is congruent to -1 modulo 8, then P square minus 1 by 8 can be written as p plus 1 by 8 times p minus 1. Okay, so because whenever we have p congruent to minus 1 modulo 8, okay, so it means p plus 1 congruent to 0 modulo 8. So p plus 1 is divisible by 8. So p plus 1 by 8 is an integer. So p minus 1 is also an integer. Okay, so p minus 1 is an even integer because p is odd. So p minus 1 is an even. So even integer times some number is also an even integer. So if p congruent to minus 1, then p square minus 8 by minus 1 by 8 is also even integer. Thus, if p is congruent to plus minus 1 modulo 8, then we can write 2 by p square minus 1 by 8, and this is equal to 1. Sorry, we this is equal to minus 1 to the power p square minus 1 by 8, and this is equal to plus 1. Okay, so according to theorem 6, so if p is congruent to plus minus 1 modulo 8, then the Legendre symbol of 2 is 1. Okay, now look at if p is congruent to plus minus 3 modulo 8. Okay, so now if p is congruent to plus minus 3 modulo 8, then so if p is plus minus 3 modulo 8 means p plus minus 3 is divisible by 8. So we can write p is of the form 8k plus minus 3 for some integer k. Okay, because whenever we have p is equal to 8k plus 3. Okay, so if we have p is equal to 8k plus 3, then okay, then we can write 8k congruent to minus 3 modulo 8, because 8k is divisible by we should write 8k minus 3 is congruent to plus 3 is 3 modulo 8, because 8k is divisible by, okay, because 8k is divisible by 8. Okay, or let me write 8k is divisible by 8. So we have modulo 0 modulo 8 here. So if we add plus minus 3 here, plus minus 3, so we will have plus minus 3 here modulo 8. So whenever the prime is of the form 8k plus minus 3, then we will have remainders plus minus 3 here. Okay. So if P is congruent to plus minus 3 modulo 8, then P is of the form 8k plus minus 3. So P square, because we need to prove our statement that the Legendre symbol of 2 for 2 over P is minus 1 to the power P square minus 1 by 8. So now we will find the value of P square minus 1 by 8 is equal to P is 8k plus minus 3. 8k plus minus 3 whole square minus 1 divided by 8, and this will be 64k square. Now we apply the perfect square formula here, so only the sign of the middle term will the middle term has sign plus minus. So plus minus 8 times 3 is 24, 24 times 2 is 48, so 48k, then plus 9, then minus 1 divided by 8. Okay, so this will be 64 k square plus minus 48k plus 8 divided by 8. Now we take 8 as common from here, or every term is divided by 8, then we will have 8k square plus minus 6k plus 1. Okay, and it is clear that this is an odd integer. Is an odd integer because for any integer k, 6 times k is even. For any integer k, 8 times k square. For any integer k square, 8 times k square is an even number. So sum of two or difference of two even number is an even number. So whenever one is added to the even number, so we will have an odd integer. So p square, so whenever p is congruent to plus minus 3 modulo 8, then p square minus 1 by 8 is an odd integer. So if this is odd integer, then minus 1 to the power p square minus 1 by 8 is equal to plus 1, and this is the Legendre symbol of 2 over p. Okay, so there is another procedure to find the Legendre symbol. So for example, Legendre symbol of 2 over 43. So this Legendre symbol is equal to, okay, let me use a smaller number. 43 is quite big. Let me use 7. So this will be minus 1 to the power 7 square, means 49 minus 1 by 2. So 49 minus 1 is 48. 48 by 2 is 24. 24 minus 1 to the power 24 is 1. So Legendre symbol of 2 for 7 is